In this lesson, we are going to see how we find the mean, the expected, or what we call the expectation, the variance, and also the standard deviation of a binomial distribution. So we saw this in our first lesson, we saw this formula. Now we are just going to apply them. So let's see the example here. In a group of 12 people, 70% are men. Find the expected number of men, variance, and the deviation. So that means in a group of 12 people means that now our n is 12. 70% are men, so meaning our probability of success is to be a man. So our P is now 75%, which is 0.75. Means that now our probability of failure is going to be this 1 minus this, which is 0.25. They are 25%. So now, if we want to get our expected number of men, so in simple terms, we are asking for us to get the mean, our E of x. We say the same as NP, which will be, now when you simplify this, we be adding 12 times 0.75. So here your answer will be 9. So our mean, expected mean, 9. And the count variance. So part B, our value of x, we said it's the same as NP cubed, which will be 12 times 0.75 times 0.25. I think this will be 2.25 times, yeah, 2.25. And the one that's in part C, to get the standard deviation, SD, which is given by the square root of value of x, which will be the square root of 2.25. And so our standard deviation will be square root of that. I think is 1.5, as simple as that. So with this, we have got that. Now when we come to this, given that a binomial distribution with mean, so here they are giving us mean, in this question, they are giving us the expectation on a mean as NP and standard deviation, so they are also giving us the SD. So our standard deviation is 2.4. Then they are asking, find N and P. So what do we have? Look at the standard deviation. Our standard deviation is always given by square root of the variance of the square root of NP cubed. Now, look at we have NP from here. Our NP, sorry. Our standard deviation, our mean was given as 9.6 from here. So it means that now our NP is 9.6, all of this. So now this will be, but our standard deviation was given by 2, is given by that. Then the square root of the all of this is 9.6, then times cube. Square both sides, we have 2.4, the whole squared equal to 9.6 cubed. So if you divide it through, so 2.4 squared over 9.6 will be giving us our cube. And the answer we have there is 0.6. 0.6 is equal to our cube. If our Q is that, then our P will be 1 minus 0.6. Our P will be 0.4. Of course, we are getting that from the fact that P plus Q is 1. We have this, then you can easily get our P. Then our N from here, know that our expectation was given by N, it's given by this, but in this question was given as 10.6. So now when we want N, we have P, so this will be our P, N into 0.4 equal 9.6. So my n will be 9.6 over 0.4, and so my n will be 24. Simple answer. So that's how we use this one. They are very easy to get. Then let us see how we handle this. A coin is biased so that the head is likely to occur is twice as likely to occur as a tail. So biased means now something is like when you toss a coin, you saw that one can occur, so the chances are 50-50. But here it's biased that when it occurs, the head is most likely to occur twice. So if n is 15, if the coin was tossed 15 times, it means that the number of trials, so they tried this 15 times. Now, we need the probability of success and failure. So, if we have a head and we have a tail, so this one, if the tail is 1, then this one is going to be twice likely to occur as the tail. So, as simple as that. Simple terms, the total here is that our total is going to be 3. So the total, when you add this and this, or you say, we have the head and we have the tail. When this one is x, then this will be 2x. But when you add all these probabilities, you should get a 1. So you see that our 3x will be equal to 1. Then from here, our x will be a third. So if these were the probabilities, it means that the probability of a head to occur is going to be 2 over 3. Then the probability of a tail to occur is going to be 1 over 3. But now, determining the expected number of heads means that now here, our probability of success is the head to occur in Roman numeral 1, which is 2 over 3. So the failure here is going to be 1 over 3. So the expected number of heads they're asking for me is NP, which will be our N was 15. And our P, the probability of success, which is 2 over 3, and so our here is going to be, this was going to be a 10. Now, number 2, the probability of getting at most 2 tails. Now here the probability of success is going to change because here we want the number of tails. Now, this one becomes the probability of success, and this one becomes the probability of failure in relation to the tail. So be careful. So probability is that x, okay, the tails, okay, let me call them the tails. Okay, let me call it the tail. The tail, at most 2 tails, at most means, let's say equal to 2. So this will be from 2 up to 0. Probability when t is equal to 2. Probability when t is equal to 1. And plus probability when t is equal to 0. Now here we say, now this probability of success here is going to be this one because we're interested in tails. Here it was this because we're interested in the heads. And now the probability here, we are talking about tails, this is going to be the probability of success. And so now, this one you can't read from the table because this value here is not there in that table. So now we have to use the partition part. So here, in this question now, our n, so 12, combination 2 into, our probability now of success is a third because we are talking about a tail. So power 2 into now the failure, now is going to give the head. So this one is going to be 13. Then plus 12 combination 1. Then a third power 1 into 2 over 3 power 14. Then plus what am I using? This was 15. Our n was 15, and this is 15. Sorry, this is 15. Because our n is 15. 15 combination 0, and then a third combination 0, then times 2 over 3 combination 15, and then here inverse. I think you can easily get that as you press that on the calculator. So that's how we handle that. We are going to see now the mode of a binomial distribution. See you. So after calculating, the value I have got is this. So make sure you get, and I'm giving it for the simple reason because from the calculator